Well, by training, I'm a biological chemist, and then I made a university career, academic career. My scientific background is in enzyme catalysis, immobilized enzymes, and enzyme molecular design. I had a group of 80 people working in that field, and recently, in fact, I started this technology transfer structure, TWB, which is gathering 30 companies, big companies, medium-sized and very small startup companies, investors, and public bodies. I think that one of the key targets of TWB is to create value and to create jobs. And from the beginning, we have created 250 jobs. We have signed an amount of 30 million contracts, and in 6 years, and we have helped startup companies to raise 100 million euros. So I think that it's very important, you know, to use the results, to valorize the results of science, of scientific research, and to turn it into applications, because this is very important from the socio-economic outlet. Two issues. The first one is that biotechnology, living systems, technology application is from the early beginning of human age. You know, since the very beginning, humans have been using totally empirically living systems to transform natural goods, plants, animals into food, feed, and drinks. You know, since Mesopotamia, people are producing beer. You know, one hypothesis that people stopped to be catchers and became agriculture farmers just to provide enough cereals to make beer. So this is working very well. Then appeared more rational biotechnology with the invention of the microscope, with microbiology, and this is a very important industry, producing antibiotics like penicillin, producing enzymes, producing organic acids, producing amino acids in the range of millions of tons. So that's a real large-scale industry. And then in the 70s appeared genetic engineering, the possibility to transfer information, genetic information, from one living system to another one. And this opens a lot of opportunities. And now we are reaching the field of synthetic biology, which means, frankly, nothing. Just that we have more efficient tools to develop applications. More efficient tools, that means that we can screen very efficiently new catalytic proteins, enzymes for application. We can engineer living organisms to turn such bacteria, yeast, fungi into plant cells. You know, they are producing a compound from renewable raw materials. That's very important to use renewable raw materials. And so it's more an evolution than a real revolution. That's the first issue. The second issue is that when you invent the mobile phone, you create a new market. And everybody can see this new market. You know, young people now, my granddaughter, she doesn't believe that you can take a picture with something else than a telephone. For us, with white hair, it's crazy. But, so, the difference with biotechnology is that biotechnology applies to already existing domains. For example, health. Health. The development of monoclonal antibodies to fight cancer. When you have a new drug, it's a new drug. It's not new biotechnology. Food. When people are using enzymes to develop new food ingredients. It's not biotechnology. it's a new food ingredient. And so on. In chemistry, if you develop the production of acrylamide, for example, it's not a new field, it's not biotechnology, it's just a new process. So biotechnology very scarcely appears by itself. It appears through the applications in existing domains. And that's a key difference with mobile phones.